Okay. So if you're looking at the Moodle page, you can see that there's not too much left in this semester. If I just show you here what's left to do, Maths for Science. We are on indefinite here, so these two are so similar, we'll actually probably get these three done in the double class today.
Today?
Yes, I think so.
But we have a double class day, like.
Isn't it a double class?
Yeah. It is a double class.
Don't worry, I can figure things out. So that just means at a minimum we have to get 3 done in probability, and that's everything that could be on the exam. So let's see.
That could be in the exam. Who's doing the exam?
Education in the exam.
No, you.
Well, I'm doing it, and then they have to make changes to it.
Yeah.
So for the semester 1 exam, it's me, and semester 2, it's them. But it's not like I can make the exam whatever I want. They have to change it or approve it or so on, which they haven't done yet. So for semester 1 in the syllabus, which is what I'm sticking by, of course, it's up until the first 3 lessons of probability. So we'll see where we are, but I'm thinking if we get finished a little bit sooner than I planned, then we just have a little bit extra revision time, which I think you'd all prefer anyways. Okay, so we're going to have a look now at integration, which, since a lot of people have done calculus already.
I haven't done it.
I didn't say everybody, I said a lot of people have done calculus, then you would also have seen integration. So what's the simplest way to explain what integration is? Yeah, Turkey, I think are you in this class now, or?
No, I think I'm in half class.
Yeah.
Go over there.
Pizza.
Go.
Integration like pizza.
You like this, but actually we don't go as advanced as that.
Before we start, still basically, you said that the probability, we have half of it for this term, the other half is next term, right?
Yeah.
Do we have to do the other half for next term, this term?
No, I just said, I'll see how I feel. Okay, hey, listen. So, we're having a look at indefinite integrals. And basically all indefinite integrals are another way of, it's like a derivative, it's an antiderivative. So basically integration or antidifferentiation is just the reverse of what we've been doing last week. So for example, last week we said x squared, its derivative is 2x, so that's the derivative. So the antiderivative would be, the antiderivative of 2x would be x squared. So in other words, antiderivative takes us back to the original. You might just want to write these vocabulary down. I kind of use these 50-50. Maybe even this one a little bit more, because I feel like it makes it clear what you're doing. It's the reverse of the derivative. But books would use both of these, indefinite integrals or antiderivative.
Oh, so it's just reversing the derivative.
It's just the reverse, that's all it is. So nothing too special yet. So we'll do a couple more examples, and then, just like with derivatives, I'll give you the table for the rules, which you'll have in the formula book. Can I go down to another simple example? So, let's say we have something like, well actually I should actually give you the notation. If we use fx, f dash x is the derivative, but does anybody know what we use if we're looking at the antiderivative? So let's say I have fx, no, not as fancy as that yet. Let's say the function is 2x, This is derivative, and I want antiderivative. Nope.
One over F.
Capital F, yes. So that would be like this. Yeah. And this would be common notation in books. To represent that the function has been anti-differentiated, we usually capitalize the letter. Okay, can I scroll down? Yeah, okay. So there is a small problem here. For example, if I have x squared and x squared plus 1 and x squared plus 2, the derivative of x squared is 2x. The derivative of x squared plus 1 is 2x, and x squared plus 2 is 2x. So in fact, if I'm starting with 2x, and I ask you what's the antiderivative, you don't know which one to go back to. You don't know if it was this one, or this one, or indeed many, many more. So actually what we say is that the antiderivative is x squared plus c. There's actually a number at the end and we don't know what it is. It's some kind of constant which we lose when we differentiate. It's gone now and we have no idea what it was. If I start here, I don't have any way of knowing which way I should go back. It could be this way, it could be this way, or it could be this way. So all our integrations will have a plus c at the end. Okay, so like I said, just like with derivatives, all of these can be done with rules. So I'll give you the table now for them. And you'll have this formula book. You'll have a formula book in the exam as well. Can I scroll down to the... Yeah. So the first one, well, you know what, actually, I'll give you the other symbol. If I want fx and I want to integrate it, anti-differentiate it, I use this symbol. And remember, if I have fx and I want the derivative, then I'd use this symbol. So this one means derivative and this one means antiderivative. And please think of this like brackets that go around the function. So for example, if I had 2fx, I can just take the 2 outside. So you need to have both. They're a bit like brackets. This is the open, or this is the start of the bracket, and this is the end. And what it says is you anti-differentiate what's inside. So this is the symbol for it. So this will make a fx, and this will make an f dash x. Okay, so you should make note of that. This is actually called an indefinite integral, but it's just an antiderivative. It's just a different symbol for it.
Wait, start and end.
I'm just saying it's like brackets. This is the start of the bracket and this is the end of the bracket. So if there's constants here, you can pull them out, just like a bracket. Okay, scrolling down. So here is fx, and then here is integration of fx dx. Okay, so the first one. And what you'll notice about these rules is they're exactly opposite of the derivative. So for example, when we had the derivative, it was you brought down the power and reduced the power by 1. Yeah? Now if you do that exactly backwards and opposite, so instead of bringing down the power and reducing the power by 1, if you go backwards, you increase the power by 1, and instead of dividing, you multiply. So in fact, this will be n plus 1 over, if it's xn, it becomes xn plus 1 over n plus 1 plus c constant, yeah. So you could test this out. I'll go back to the table, but let's just test it out quickly with 2x. So what's the power here if it's 2x? It's like power 1. So if you increase the power by 1 and divide by the new power, you get the x squared we were saying earlier, plus the c. Okay, so that's xn. Sine x is minus cos x plus c. Cos x is sine x plus c. Ekx is 1 over k ekx plus constant, yes. Did I leave out log? Yeah. 1 over x will be log x plus c. We don't have tan for this, I don't think. I think that's only semester 2. Let me have a look at my questions. Yeah, that's only in semester 2. And the last one? What? Good. 1 over ax plus b. That would be 1 over a log ax plus b plus c. Okay. Please note these. There's more, of course, which we'll see in semester 2, but for semester 1, I think this is all you need for the exam. Continue? Yeah. Let's have a look at our first example then. So for example, we want to integrate 2x cubed plus 3x squared plus 2x plus 4 plus 4 plus 2x plus 4 dx. So the first thing I'll do, just to make it really clear, is I'll put all the powers in. So this is x squared, this is x1, and then what about the 4? It's like x0. So remember the rule, we increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, increase the power by 1, and divide again, and increase the power by 1, and divide, plus c. So we have a half x4 plus x cubed plus x squared plus 4x plus c. Okay, I'll give you one to try now that's like this. Yeah. Okay, can I scroll down? I want you to try this one now. Integrate 1 over x plus 1 over x squared plus 1 over x cubed dx. Oh, by the way, for the exam, I think exactly this one was a section A question. So these ones would all be like section A questions, maybe 4 marks or something. So try this one. And again, like the last one, you should get all the powers first. Okay, do we have this one? Yeah. So, this one here is x minus 3. This one here is x minus 2. And this one I won't change. And the reason is, this is actually exactly in my formula book, exactly like this. So this one becomes log x. This one becomes x minus 1 over minus 1. And this one becomes x minus 2 over minus 2 plus c. So the answer is log x minus 1 over x minus 1 over 2x squared plus c. Okay, please write that down. A common mistake is students forget that this is log, and the other common mistake is student thinks all of these are log. Very common mistake to make here, so please be careful with this one. Okay, let me give you another example. So try this one now. Yeah.
I thought you said the whole point of the integration is that when you differentiate it back,
It should, yeah, if I differentiate this, it should return back to this here at the start. Yeah?
the last two that you have.
Yeah? You don't feel like they'll return back to this? Let's check it so. So derivative here, well, this will be minus x minus 1 minus 1 over 2 x minus 2, and this is log x plus c. Okay, derivative of log x? 1 over x. And this one, bring down the power and then reduce the power by 1. Bring down the power and reduce the power by 1. C becomes 0. So it's 1 over x plus 1 over x squared plus 1 over x cubed. Yes? Okay. Right, let me give you another one to try here. So try this one. Root x plus 1 over ex plus sine x dx. Hey. Save some for the rest of us. Okay. Yeah. Join the queue, okay? Don't be skipping the queue. Yeah? Now, we have this one. So, first I should change this into x power a half. And also I should change this into e power minus x. Yeah. Now I can use my formula book. This is x power 3 over 2 over 3 over 2 and this would be e minus x over minus 1, and this would be minus cos x plus c. So this would be 2 over 3 square root x cubed minus 1 over ex minus cos x plus c. Usually in the exam they're happy for you to leave it like this, but sometimes they want you to continue. But I'd say 90% of the time this is okay, and only 10% of questions would ask you to continue. Yeah?
Can you make it like 2 to 3x 0 to 2? Like that.
Oh yeah, just don't
I didn't.
do that part. Yeah, that's fine. That'd be fine. Yes?
Then the square root of x all cubed, is it the cube root of x, then the square root?
Yep, you could also write it like this, square root of x cubed. This will be valid as well. So you could, and up here we wrote it like the x power 3 over 2. So you have actually 3 ways of writing it. Square root of x cubed as well. So either of these will do. Yeah. Okay. Continue? Yeah. Okay, so like I said, this lesson isn't very difficult. It's just really using the formula book, and the next lesson also isn't very difficult. So in the first hour we'll get the 2 worksheets done, and then for the second class we'll have a look at the last worksheet for calculus. So what I want you doing for a few minutes in question 1, let's see, we'll say B, C and D, and then question 2, all of them, and then question 3. Now this one here, I didn't show you how to do this one, and it's not really going to be on the exam, but I think it's good if you try one of them to see if you can figure it out yourself. But these two, these are really basic section A questions on the exam, so really you want to do these like in 1 minute per question. These should be quick questions to do. So you can try these please for a few minutes. Did you write this down? I want to post this.
Yep.